which reminds me I should be recording, right? So if you need this, go back in Google Classroom and watch that video or follow the YouTube playlist. We also went over page 2 yesterday, transferring fractions to decimals and decimals to fractions. Remember, if we can say the decimal, it makes it easier for us to change to a fraction. And then yesterday, we went over converting improper fractions to mixed numbers and mixed numbers to improper fractions. So let's review that with a couple more of these, and then I'm going to give you a few minutes to practice these on your own. So remember, if we are, okay, well, I can add you to the class in a little bit. You don't need your Google Classroom right now. Yes. Yes. Yep. But let's not interrupt right now. Just a second. Yes. But let's not interrupt right now. Always okay. You don't. Yeah. But that's interrupting. You see that? You're fine. You ready? All right. So here, remember, we're going to multiply the whole number times the denominator. What's 1 times 12? 12. 12. And then we're going to add it to the numerator. What's 12 plus 5?
15.
No.
No. Oh, yeah.
12 plus 5 is 17.
Oh, yeah.
Some of you might want a calculator. Good grief. All right. Now, what's our denominator? Staying the same. So we're keeping the 12 on the bottom. So that's our improper fraction. The other way, look at this one in the next row. 43 divided by 7. How many times can 7 go into 43? Use your multiplication table if you need it.
Wait, so the 6 times the whole number is like divide?
6. Yes, that fraction bar always means divide. So we're changing it into a mixed number. 43 divided by 7 is 6, but 6 times 7 is 42. So we have 6 remainder what? What's remaining? What's 43 minus 42? 1. We have a remainder of 1. So we write that remainder as a fraction out of what we divided by. We were dividing by 7. Okay, so take about 5 minutes or so and practice this. I'm going to pause the recording so you don't have to watch the whole thing. But we aren't going to go through all of these. We'll go through a few. All right, give those a go. Just a few of these. So I'm going to hop down to the last 2 rows. 75 divided by 8. How many times can 8 go into 75? 8 times 8 is 64. 8 times 9 is 72. So I will have a little bit of a remainder. What's 75 minus 72? 3. I write the remainder over my what I divided by. What was I dividing by? I was dividing by 8. See, I said 75 divided by 8. So my denominator is going to stay the same. It's still going to be 8. So 17 divided by 2. How many pairs can I take out? 8. Yep. So 8 times 2 is 16. So I would have 1 remaining. Would it make sense for me to have 2 remaining? If I had 2 remaining, it would have gone in 1 more time, right? All right, so the other way, remember we're multiplying the whole number times the bottom number. What's 7 times 8? 5, 6, 7, 8. So 56 plus 1 more is 57. And it's keeping the same denominator. 85 divided by 9. So 9 times 9 is 81. So I can take at least 9 full groups out. How many would be remaining? 4 out of the 9 to make a whole.
You don't math stands for.
Yes, I do. Mistakes allow thinking to happen.
Oh, I had math addictive things to
All right, so be sure we're understanding this process both into a mixed number and into an improper fraction. Lots of parts that we have to review and remember. Now we're gonna try and remember our integer addition and subtraction. With this, a few notes that we've taken before, but good for review. Remember, when my signs are the same, we have to find the sum. This means we're going to add, right? When my signs are different, what are we going to do? We're going to find the difference. Good, I say this a lot. Which means we have to subtract. How do we determine our answer? Our answer is the same as the sign of what? The bigger number. Remember, we're talking about the absolute value of the bigger number. So here, even though -8 is less than 3, 8 is still furthest from 0. So we're thinking of this as the bigger number, so our answer is going to be negative. Now remember, don't forget, we might have to keep switch. So we might have to keep the first and switch this to subtraction. I'm sorry, switch to addition from subtraction. And switch the sign of the second. So this was keep. Keep the first, switch to addition, and then switch the sign of the second number. Lots of things to remember when we're adding and subtracting. So I'm going to go through one column, and then I'm going to give you the other 2 columns on your own. We have addition here, so we don't have to change any signs. Our signs are the same or different? Different. So I find the difference. Big minus little. What's 8 minus 3? 5. My bigger number is negative, so my answer is negative. Is this addition?
Yeah.
Oh, it's not. We have to switch it to addition, so we have to add the opposite or keep switch. Now, don't we just have 6 plus 4?
Yeah.
Yes. So what is 6 plus 4?
10.
10. Here, don't try and make this complicated. What's 6 minus 5? 1. This fourth one down. Are our signs the same or different?
Same.
They're the same, so we're finding the sum. What's 8 plus 2?
10. -10.
Is 10, but both of our signs are negative, so of course our bigger one is negative. The next one, are our signs the same or different? Different. So I have to find the difference. Big minus little. What's 10 minus 8?
2.
2. And the sign of our bigger number, 10 is bigger than 8, so our bigger number is positive or negative? Negative. So our answer also has to be negative. Now we have another subtraction. We have to keep, switch, switch. We keep the first. This is only when we have a subtraction problem. We switch, switch. Now we just have 8 plus 2, which I hope you can do, right? What's 8 plus 2? 10. Good gravies. All right. Now I have an addition problem, so I don't have to switch anything. Are my signs the same or different? I have a negative and a positive, so they're different. So I'm finding the difference. Big minus little. What's 6 minus 2? 4. And my bigger number is 6, which is positive or negative? Positive. So my answer is going to stay positive. If I take 0 from anything, it's just whatever that anything was, right? We're not moving on the number line at all. Here, again, we have a subtraction problem. So we have to switch, switch. We have to switch to addition, switch the sign of the second number, right, Michael? So we keep the first. We switch to addition. We switch the sign of the second number. Now, looking at from an addition standpoint, are my signs the same or different? Different. So I have to find the difference. So I am subtracting big minus little. It is 1, and my bigger number is positive. So my answer is positive. Don't be tricked by this next one. What's 7 minus 4? 3. So you could rewrite this as 7 plus a negative 4, but there's not really a whole lot of reason to, because we know 7 minus 4 is 3. That's one we should have committed to memory. Keep the first, switch to addition, switch the sign of the second number. And again, what's 8 plus 2? 10. Nice job with yourself there. All right. So that's the first column. We got about 5 minutes for the next 2 columns. Clip along at a decent pace. Think them through. It's okay if you don't get through all of them. We're just doing this to practice. Eventually, we'd like to have the whole packet done, but get a few practice in. Another day we can practice more, right? So just to go over a couple more of those while they're kind of fresh, I'm just going to look at these bottom 6 here. So remember, we're going to keep, switch, switch. Now our signs are different, so we're finding the difference. What's 6 minus 5? 1, and our bigger number is positive, so our answer is positive. Hopefully these are getting really quick. The better you are at these, the easier next year will become, right? Our signs are different. We're finding the difference. What's 5 minus 2? 3, but our bigger number is positive, so it's positive 3. Here our signs are different, so we're finding the difference. Big minus little. What's 6 minus 2? 4, but our bigger number is negative, so negative 4. Here, when we switch to addition, switch the sign of our second number. What's 9 plus 9? 18. Here, when we keep the first, switch to addition and switch the sign of our second number, right? We can't switch to addition and just leave it. We have to switch. So our signs are different. Big minus little is 6, and our bigger number is positive. And you know that 4 plus 1 is, of course, 5. So that didn't leave you with too many more to go through for your practice, but hopefully we're still coming along there. All right. Today we have to start remembering how to add fractions. These should be quick and easy. Notice these are like fractions because they have like denominators. Remember, denominators are the bottom number. When we add subtract, our denominators stay the same. Denominators stay the same. Now, that means that in order for you to add them, we have to make them the same. So we're not making them the same yet. We're just practicing what we would do with fractions. Do you notice whatever our denominator was, it stayed the same? So 7 plus 2 is what? 9. We can do this now, right? Whatever's on the top is what we do it with. What's 7 minus 4? 3. What's 9 minus 7? 2. What's 7 plus 6? 13. What's 8 plus 6? 14. What's 7 plus 7? It's 14, but is that what I do with my denominator? No, my denominator has to stay the same. We're not simplifying, we're not changing to mixed numbers or improper fractions yet. We're just leaving it as it is because I want you to understand that our denominator is staying the same. We're just adding across the top, right? 12 plus 7 is 19. 15 stays the same. So we have 19 pieces now out of the 15. If I have 11 of something and subtract 7 of those same somethings, what do I have left? I have 4 of those somethings left. So make sure your denominator stays the same. I'm going to give you a couple minutes to finish this page because it's not too involved, and I do want to look real quickly at the next one. So clip along. You're just adding or subtracting 2 numbers on the top. The bottom number is staying the same. All right, hopefully that makes sense. We added or subtracted across the top. Remember, you're going to be dealing with integers in some of these cases, but our bottom number, when we're adding and subtracting fractions, always needs to be the same, which leads us to what we're going to go into depth more tomorrow, but I want to remember and review this right now. So you'll see it today, you'll see it tomorrow, and then you'll practice tomorrow, okay? So don't put anything away, hold tight. We have to find equivalent fractions with the same denominators. So we're looking at our denominators and we're talking about their least common multiples. So between 3 and 2, what would be their least common multiple? 6. So not their common factors like you're thinking, I can tell. We have to write them out of 6. So we asked, what did we do to the bottom to get 6? 3 times what is 6? We multiplied the bottom by 2. So whatever I did to the bottom, I have to do to the top. What's 2 times 2? 4. How did I change? What did I multiply the 2 by to get 6? 3. So 2 times 3, whatever I did to the bottom, I have to do the same thing to the top. So now, isn't this just what we were doing?
Yeah.
Yes. So what is our new denominator? 6. And what is our numerator? 7. Good. 1 and 1, 6. Very good. Awesome. So eventually we're going to practice simplifying and changing those into mixed numbers if needed, but otherwise we'll be good to go. You guys have a couple minutes, so be sure you're caught up.